random variable x is a normal distribution of variance 10. It has these values. Obtain a two-tailed test. Okay, so very quickly, okay, I'm gonna move a little bit faster now. This first definition. 2, you want to do a two-tailed test. 3, you state the level of significance. 4, the test statistic. I'm not going to go through already, okay? Very fast. All right? Z is x bar minus 8 divided by square root 10, because the variance is given. Variance is 10. N is 8. You collect 8 pieces of data. Now, the only difference between example 2 and example 3, first, have attention. Example 3 is a two-tailed test. Example 3 gives you individual data. So, what we will do, okay, the keystrokes are all there, I don't want to elaborate. What you can do is you create an L1. I'm not going to tell you how to do it, okay? That means you enter all the 1, 2, 6, 7, 8, 9, 20, 26 here. Doing the same steps now, you enter it as L1. So when you do this, instead of, after you enter L1, instead of using this tab stats, you do data. Okay? Then you enter the same thing, your mu naught is 8. Your standard deviation is square root 10. Don't forget your square root, all right? Because they're asking for standard deviation. Now this one is your L1. I have not entered my L1, but you have. If you have, then just put it as L1. Frequency is 1. What you're saying is there's only one value. What you're saying is only one value of 1, one value of 2, one value of 6, one value of 7, one value of 8. Okay? Okay? Then you do a two-tailed test. This one must do a two-tailed test. Then you press calculate. Press. Yeah, I won't get the answer because I didn't enter that one. So eventually, you should get this screen. Most important value is my p-value. Most important value is the p-value you're going to obtain. You're going to use the p-value for decision making. Small means rare, reject H naught. Big means not rare, do not reject H naught. Simple. So, computation. This one must put, okay? This one is step number 5. Therefore, from GC, actually, this is given, you GC calculate for you, or you can calculate on your own. Or no, this is useful now because, look, the GC help you calculate our x bar because the question gives individual values. The question help us calculate x bar now is 9.875. From GC, p value is 0.0935. Since p value is 0.0935, it's smaller than 10%, smaller than 0.1. Correct? Rare. The conclusion is what? Okay, practice. Talk to your friend. Help. Write in pencil, okay? The conclusion. Okay? Write in pencil. What should you conclude in context? Okay, give you 1 minute. There is what? There is sufficient evidence. Yes. But the calculator help you calculate. You must trust the calculator. The p-value already the correct p-value. Because you specify details, you specify details already. It's for both sides. Later I explain. Okay, must conclude, okay? There is sufficient evidence that the population mean is not 8. Because it's a two-tailed test, there is sufficient evidence that the population mean time is not 8. Done. Okay? Got time or not? What time? No time lah. What am I talking about? Population mean is not 8. Right? There's no such thing as time. No time. Okay? Population mean is not 8. So this is our step number 6. Correct? Okay. Now this one I must stress. Look, I don't know whether you recall. When I introduced p-value, I said p-value is the probability of obtaining a value as extreme as the observed value of x. Now, let's look up here. My calculator actually helped me calculate my normalized z value is 1.677. Okay, let's look at this 1.677. Okay, so which means my observed value is 1.677. This is observed. Okay, this is 1.677. Now, this is my z. But because this is a two-tailed test, the area of this is not the p-value. The p-value is probability of obtaining a value as extreme as the observed value, which means my p-value is this. My p-value is this plus this. Follow what I'm saying? So I'm going to say this, okay? This is p over 2. This is p over 2. Okay, maybe, okay, okay, sorry. I want to be more specific now. The calculator help us calculate, what's the value? 0.0935. The calculator is not wrong, okay? The calculator already helped you sum up. The calculator 0.0935. This is 0.0935 divided by 2. This is 0.0935 divided by 2. The calculator already helped us sum these two up to tell us the final p-value. Do you follow what I'm saying? The calculator already helped us sum up these two areas and tell you it's 0.09. But if you were to calculate the p-value on your own, you must be extremely careful. Then you use this idea. P-value is 2 times of this, which is actually equals to 2 times of probability z greater or equals to 1.677. It's the same, correct? It's the same. This is a normalized z. All okay. I'm saying this because a lot of us can get very confused. But just remember, your calculator already helped us calculate the correct p-value. But if you were to do it by hand on your own, you must be extremely careful. You must take two times that. This probably. Follow? All good? Okay, excellent. Okay, now we move on a little bit. Okay? Throughout the example 1, 2, 3. Oh, sorry. Maybe we stop the video early.